I'll not focus on something specific or on a specific technology, but when I think about baggage handling and cargo handling, for me, there's always this question that you have this very complex process that has many stakeholders. And Rico, next slide, please. Where you have to kind of integrate various stakeholders with many different processes into a confined space and a confined timescale. You have your warehouse, you have transport, you have loading, unloading. So I'm always asking myself, how can we best as an industry use technologies that are already there, combine them in order to get a holistic view on baggage handling, on cargo transport, cargo handling, but also an improvement on those two things. And I think there's not a one-size-fits-all approach. Some say, yes, you should do it like this. Others say you should do it like this. Then you have new technologies like the one that Eric just presented, where you have a new hardware that will make your life easier. But in the end, it's still a very opaque process. So for me, the key is to integrate and combine various technologies to achieve really the most optimal result. Next slide, please. For this, I'm looking at how can we cover the process from A to Z. So from the warehouse, from the baggage hall, over transportation to loading, unloading. And now in my example, I do focus a little bit rather into the warehouse, so into the cargo area. But the same holds true for baggage handling as well. So let's start with the warehouse and the baggage hall. Next slide, please. So first of all, we have to ensure that we use our resources as optimally as possible. So what are the resources? That's our drivers, that's our dolly trains, that's our ULDs. We have different kinds of cargoes, different kinds of passenger baggage. We have tail-to-tail baggage, we have express cargo, we have pharma cargo, now we have all the vaccines. So they have different importance levels, they have different requirements from a handling perspective. So first and foremost, I think we need to use a state-of-the-art system to create optimal dolly train combinations, ULD or pallet dolly train combinations. For this one, you can, for example, use a resource management system. One that I know of that has this functionality is, for example, the Informs GroundStar real-time system. I guess there are also others, Workbridge and so on and so forth, that can do this. But basically, we have to first not have a manual process of saying, okay, this pallet goes onto this dolly and so on and so forth. So that's your first part. The second part is that we have to think about safety, about making sure that the ULDs, the baggage, the pallets are correctly loaded and locked on the dollies. So are they in place? Are the locks up? For this one, we could, for example, use video. We could use a video camera that is looking on the dolly train and then use a technology such as the one we use at Assaia in order to automatically detect if the locks are up. Then we want to understand if we have a correct combination of ULD and dolly. So because in step number one, we optimize to have the perfect combination of ULDs on the dolly train so that it goes quickest to the aircraft. And here we can, for example, use a combination of video and GPS-based technologies. Next step is that we also want to understand if the dolly train is, for example, correctly positioned on the right loading ramp or is correctly positioned in front of the loading ramp. And this one, for example, is something that we could achieve with a GPS sensor. So to make sure that the right dolly train with the right dollies, with the right tractor, with the right driver is in front of the right loading ramp. That indirectly feeds back into the RMS because you also want to update your task status. And then last but not least, especially in a warehouse or in a baggage hall environment, You have certain areas where you want to only go 5 kilometers per hour or 10 or 15. So we need to track speed. And that one, again, can be done by GPS. Now, next part is transportation. So first and foremost, during the transport, the dolly is out there in the dolly train is out there in the field. And we somehow want to understand what's the current status, where is it right now? So again, that would be something that we could do via a GPS tracking device, and see, is it landside, is it airside, where is it airside, how close is it to the aircraft, and so on, to always understand what is the current status. Because in the end, when we look at it from a holistic perspective, what we want to achieve is predictability, reduction of variance, and transparency. Then we continue with the tracking of task status. So is it moving? Is it not moving? Has it passed certain milestones or like geographical positions? Again, that could be done via combining video and a resource management system where you originally allocated a task to a driver and to maybe a tractor. Then you, at many airports, especially from a cargo handling perspective, not so much from a baggage handling perspective, you also often have to go from a landside warehouse to an airside warehouse. So that means you have to go through a security gate. Now, in the old days, no one really knew how busy a security gate was at the moment. And even if you knew it, you didn't know how busy maybe a second security gate was. And there was no possibility for you as a driver or as an allocator to quickly calculate, okay, is it quicker for me to send the driver to a security gate that is maybe a kilometer further off, but therefore the person only has to wait like 1 minute? Or is it quicker to send him into the security gate where he has to wait for 10 minutes? Now, with the video, we can, for example, understand what is the current waiting time in front of the security gate for every security gate. And then in the background, we know, okay, based on the GPS data of the dolly train, we understand, okay, it's quicker to actually send him into the very full security gate because it's quicker than driving another 1 kilometer and using another security gate, or the other way around. But at least we have this transparency, we have the data to actually look into this. As a next step, it is also important to monitor the vehicle status. That goes a little bit into Richard's part where we say preventive maintenance, predictability of are we within the operating envelope. And again, that is something that you can do via GPS data, via sensors that track constantly what is the current state of the vehicle. And to some extent, for example, from an outside perspective, we could also use video and see if the vehicle is moving or not moving. And then last but not least, also, while we are on the airport apron, we want to track speed again when we are in speed restricted zones. Next slide, please. And then eventually, we arrive at the aircraft, or we are at the aircraft and wait for cargo or baggage to be unloaded. So in that area, we want to also do a lot of timestamping. When did the dolly train arrive at the stand? When did the first ULD or the first pallet or bag was unloaded from the dolly train, and so on and so forth. So this could be done, again, via a combination of video to detecting when the dolly train was actually arriving at the aircraft. We can send this information then to the RMS, which can update the task status, which can maybe recalculate if the task is delayed or not, and then kind of also replan the following task to arrive at a new optimal. From a KPI perspective, many airports are nowadays also required to present to the authorities when the first bag was on the belt out of the aircraft, or when the first bag was on the belt into the aircraft, because they otherwise have to pay fines. So from that perspective, that is also something that we can, for example, detect with the cameras, with the video. And then last but not least, and I think this is something that is really, really cool. What we can also do is if we have a camera, for example, installed at the high deck loader, we could, for example, even scan QR codes that are attached to a ULD or a pallet. Like when I speak about ULD, I mean the boxes. And then we can scan them when they go into the aircraft, and, for example, can connect them to a certain position, or at least say ULD 1 with the unique identifier 1234 went into the aircraft first, so it's probably positioned in that position within the aircraft. So and for me that is kind of the essence, where I say if we think wider and really not only look at one technology or at one specific area, but if we take a holistic view, there is a lot of stuff that we can do in order to improve the overall process, make it more reliable and more transparent.